This is a nice bike. But unfortunately, it's got an issue with the kickstand. It makes it really hard to put the kickstand down. You got to lean on it just so. And even then, you can see how much play there is here. So what we're going to do today is put something other than a bungee. Everything's chrome and nice, and you got a bungee, right? So we're going to clean that up.
Brian's Mobile One.
This is the finished product, how it looked, and here's how it worked. Now it's just a teeny bit. That's it. Smooth and quiet. Why? Why did we spend all this time and work? I'm about to show you how we did this. This big, beautiful motorcycle is also really heavy, and the only thing keeping it from falling over and sustaining thousands of dollars of damage is this little kickstand and this little bolt. Now, they're up to the task, but they do wear out, and this one's got a lot of wear. Eventually, you can guess that if it wears at the rate that it's been wearing, it's going to wear out and it's going to fall over. The owner will go to lean it over a little bit, and it'll just kind of go a little too far, and then what's left of this floppy, droppy kickstand is just going to snap. I say this was floppy, sloppy, and droppy. This is why it was droppy. The spring was broken or missing. It was sloppy because the engineering was poor. The frame is continuous from here all the way to this part here. And so the wear that happened on this and the kickstand and everything else made it so that it was really floppy. This motorcycle is equipped with a little switch. It's got a bolt here, so that bolt doesn't go to the frame, it just goes to this switch. It has that so that if you go take off on your motorcycle in gear and go to turn left, you don't crash. I'll show you how it works. So what we're going to do is we're going to add some metal to that. It seems to me like the hole isn't round either. We might have to do a little fill in on that. This is in the way of getting to that and dealing with this because I want to be able to weld and grind and all that. So I'm going to take the rear shift pedal off. It's just this bolt right here. And I'm going to take this off. It's just these two bolts here and here. But you can see all the tools that we have involved. We've got small impact, big impact, flap disc. It takes a lot of tools to fix things like this, or it takes a lot of money. In this case with the frame, it would take a lot of money. The money you would spend on replacing the frame of this bike and the labor and everything, you could pay, literally you could pay for a welder, flap disc, this, that, and the other, and then you have all of these for later, so net win in the long run. This frame, however, it has a separate thing on the left side. You can see this is where the kickstand is. That part is only like $400, and then other ones, it's just not available at all. So you see, it could be more expensive or cheaper and better and more effective to weld it or not, just depending on the scenario. You can always put metal back with a welder, and then you don't have to wait for the shipping. So let's get to it. Let's fix this thing. Step one, have the bike stay up without a kickstand. You may ask, Brian, how is the bike staying up if you don't have a kickstand in the down position? And the answer is, just use a strap. You can see I've got a strap going between the handlebar and this right here, and then I've got a little screw to keep it from flying off. You can tie it off, you can tie it up, you can like have straps from here and then hang them from the roof. Just whatever it takes. There's a lot of ways to get it to not fall down. Another way is that you can pile up blocks, rock it onto those blocks, put more under the other side, and so on. You can see there's an index for the shifter. So there's an Allen bolt that holds that safety switch on, and to access that I'm just going to pull the beauty cover off here. This safety switch is a fork in the road. That screw is not going to come out the bottom even though it seems like it will. So if you go my way, you take off the cover and it costs you a couple of minutes instead of costing you $50 and some shipping time. Just think hubcaps. There we go. That is not clean engineering right there. Looks like we'll be pulling this guy off at this point. So off comes the second shifter, and that's what this other mark's for. You still can't get to it. I can see why they did a beauty cover now. This is not a good looking setup. Okay, so with a conventional Allen wrench, you can get the clearance. Let me show you over the top what I'm talking about. That's what I'm talking about. I think in engineering school somewhere, there's a statement or a law, in fact, that states that an engineer, in order to do a safety device, has to interfere with other operations and make it as impossible to get off as possible. And emissions, same story, but in reality, it's afterthought engineering. Oh yeah, we got to do that. Let's go to lunch. And we met budget. Using a T-handle is ideal for this. If you got them, use them. Dun, dun, dun. We're free. Slide it off, and voila. Sweet victory. That did not come out as easy as you would think. It's got all kinds of binding. Look at the wear that's taken place there. As you can see, we've lost a lot of material across the face, but we don't really know how much. But we can actually measure and find out exactly how much we got to do. So that was a lot of movement that was happening at the kickstand. And in reality, the wear places that it lost material is 1, and this is out of round. 2, and is that this got worn off, and this is the main concern. 3, this bolt's worn out. You can see a little step right here. 4, this part of the kickstand, and 5, where this has been rounded out. If I were to do this again, I would order this bolt along with the spring and the nut and just have them on hand, and that way it would save you a bunch of time. If you got a spare $100 sitting around, you can replace the kickstand at the same time, or you can do what I'm about to do and just weld everything. First thing we're going to do is take off more. The reason being is there's a lot of impurities and rust and everything that'll cause our weld to not stick, and so take that off with a flap disc. Less impurities means less troubles, bubbles, and less filler that we have to do with something else. If you're not sure what you're working with is ferrous or not, it basically means that you can weld on it. You just put a magnet on it. Yeah, you can weld stainless and it's not magnetic, but that's a video for another day, and it's coming soon. This right here, that's going to cause some play if I let that go. If you're a goofball like me, you're going to try to repair this. The smart thing to do is to just order a new one when you order a spring or whatever other things you got to do for your bike. But just sitting as it is with the worn bolt and the worn hole, look how much of that wiggle is all right here. Some of that is because this is missing, and some of that's because some of the bolt's missing. I'm still set up for stainless steel from that exhaust that I did. So we're going to pull this off and go for mild steel. There's a bunch of different places to measure, so where do you start? I want to make sure that I get up underneath of here because there's a round wear mark, and I think that that was machined in to some degree, maybe not, but you see these lines coming in from right here and then back also here. So they went thinner for the kickstand. Pardon the shaking, it's kind of an awkward shot. So I want to measure close to right here and here and just get as close as I can to that. The main problem is just this face right there. If we can get anywhere close to that and get it somewhat flat and smooth, it'll bode well for the kickstand. Every motorcycle has a little bit of play right here, but this is just ridiculous. This is just way too much. We're going to work on what we can to make it a little bit more predictable. This is kind of a process that requires that I measure and check and grind and check and grind. And I'll do a little bit on the welding side, but mostly on the grinding side. So right here I'm at 12 millimeters, and here I'm at 8 millimeters, so there's a loss of 3 millimeters on the face of this. First thing I do, scrape up the paint on the smallest, easiest to fix, easiest to patch, nobody's going to see it spot, and that happens to be right here. So I took my flap disc and ground that off. The better ground you have, the better weld you're going to have. We're about fixing things and making them better, and sometimes you got to take a step back before you can take 10 steps forward. So the best calipers to get, these are the best ones to get. They're digital. You can zero them out so that they're nice and consistent, and then you can get them switched off to where you got a metric units and garbage units, imperial units, whatever you want to call them. Let's pick something that crosses over. We'll go 13, the intersection between metric and standard, and it's a 1/2 inch. So we're going to dial that off. We're going to hit the button, and we're going to watch a switch to say it's 0.5 inches, and we're going to hit it again, and it's going to say 33/64. So I'm trying to get at 32/64, but you get the idea. It's a 1/2 inch. And we're just going to use our wheel for precision. You see right there, 1/2 inch. We're going to lock it out, and then we're going to switch again, and we're at 12.69. That's funny. So 1/2 inch. So you can see in the metric says, I just learned something new, because I always thought that 13 was right at ½ inch, but apparently it's a little bit off according to this. The accuracy on this is better than what it is on a spanner wrench, because a spanner wrench has to have a little gap to be able to fit on there. So anyway, these are pretty cool. So you can measure the outside of something, you can measure the inside of something, and on the bottom you can also measure the depth of something. I see that this depth measurement, like you measure down inside a hole, and it'll give you the depth when you bottom out with this. A lot of your cheaper ones don't have that. It's nice to get one that's a stainless hardened. I got one on air for, and then I ordered this one on Amazon. Paid a little bit more for this, waited a little bit more for this, but it's just so much nicer to work with. The case is better too. I'll leave a link in the description. This is one of those tools that you just don't find in a lot of garages, but you just have to have. It's so important to be able to tell what size your bolt is, or how big of a gap is something you need to make. But if you're going to create, engineer, or do anything, or repair stuff, you need to have one of these. So do yourself a favor and click the link and get it. Look at this one, and of course I really like the metric system. If you go here, we're at like 12.5 millimeters, and then you look in here and we're 13 millimeters, so don't have a long way to go there. But you get to the end on the very tip, and we are at over 13.5 millimeters. Let's see if we can get everything at 12.5. That should do. You want a little air gap. You need a little place for the grease to live. You just don't want to be sloppy, right? Yeah, I just got this in the mail today. One of the things this does is it has auto shut off. A lot of the cheap ones do not. All right, we're all set up. I've got my ground. I got this set up. I got my helmet. This thing's ready. I just got to swap my ground clamp. I can hit my bolt and then swap the clamp to this, and I can get the inside of here. Let's begin. So there's the first bead. Just fill that in a little bit. It was like 8 point something. We're already up to 11.
Let's go to 11.
In between passes, I'm going to get all the dross and burn off. I'm also going to try to make up the hole by welding a little bit on the inside right here. Let's do it. So I'm just piling it on thick. You can see how much I'm sticking up. It looks like a ton when you're here. When you get down here, it looks pretty level. All right, let the flapping begin. So you can see it's starting to take shape again. It's still bulging a little bit here. I gotta take that out. You can see we're just about there. It's pretty well filled in. I'm into this 5 minutes or less. Getting everything set up and getting down to it, that takes some doing. We're going for right at about 12 and a half. So 11.62 is pretty close. I took a little bit too much off, but not much. Let's throw the kickstand on now and just get an idea for where we're at. Put my finger on it too much. As I said before, I may have to do a little filing on the inside because I made up the inside that was wallowed out. This hole is an oval. You see it looks more round now? That's because I did a little weld on the inside corner. So in essence, we're getting 4 out of 5 surfaces back. Let's see if we can get this bolt to go in the hole. And we can't, which means we've got a good tight hole again. I'm gonna get a chainsaw file, a round file, and I'm gonna hit that little burr right there. This chainsaw file, and it's a good file. I mean, it's fast. It's made to cut something that's made to cut. It's hardened steel stuff. See how good that looks now? It's pretty circular. Some of that is my skill, and some of it's just welding tends to flow out and want to be a certain way. So I've got a little bit of a wiggle, but not near what I had before. But it's still a little wiggly. So I'm going to see if I can get some weld in on here. I won't be able to get all the way to the inside, but I can get the edge of the outside, and that's all you need to keep it from being too floppy. So I'm going to get this surface right here, and I'm going to get that right there, and that right there. I want my stick out to be correct. I'm just going to kind of guide it around with my thumb like this. So you can see I've got a little bit of a corner to work with now. Then I'm just going to get these corners here. Let's see what that looks like test fitting on the bike. It probably won't even fit on. It almost kind of fits on. but it's getting really tight. That's what we're looking for. Now I just need to open it up enough. I'm excited. This is going to turn out awesome. Look how tight it is already. We just need to make it be able to clear all the way on there. We can put this back together after we give it a little paint and a little grease. So this is kind of where the lion's share of the work happens, being really meticulous and measuring and cutting and measuring and cutting. Of course, a lot of it's going to be by hand. I do have a little bit of help for the macro stuff. For example, where it sticks out on the edge here, I'll be using the grinder for that. Width here, so this one's 7.4 millimeters. And you come out here, it's 7.17. Look at this side, it's 6.64. So we want to aim for about 6.64 here. It's to just measure the inside gap. Make sure the inside gap is about 12.6. Remember, we want the other one to be about 12.5 or so. So we've got just a little bit of gap. That'll keep it tight. Coming along pretty good. It's time to go to the vise and do some hand filing. See, here's what we've got for the halftime show. Trying to be careful not to go too far, so it's time to stop, collaborate, and mic it. Alright, so you gotta be careful how you mic it. We're going for about 12.5, just a little over 12.5. We got it here. Let's see what we're doing on the inside. The inside, we're still at 11.8, so I need to take that in some more. Looks like we've got room to do that. But we're more square now than we used to be. Coming along, we're getting close. So 11.4. So it's time to give it some more. This is what I do. That thing's in the way for the neutral or kickstand safety switch. I've got it leaning against the workbench like this, and it's supporting the vise, and that way I can just really lean into it with the file. Kind of going like this. Again, I used a cutting disc for the initial part. This doesn't rust because it's got a coating on it, but where we've welded especially, we're using mild steel wire. Probably could have used stainless steel on this, but I don't want to be here all day. That stuff is really hard to file, but it could make it wear less. So I've got this to where it's pretty tight. Everything's looking pretty square. It's got a couple of holes in it, you know, just little nicks and whatnot from the void. Don't care, nobody's gonna see them. This one's got a little void across the top. But I went to test fit it and I couldn't get it to thread in. Upon closer inspection, guess what I found? I found a little blip from welding right there. And there's another one on the other side. At the bottom there, you can see it there at the very bottom. I need to clean the threads out on it. To do that, I need to know which of these to use. Find that, I've got a trick. Check a thread. I go down along these. I know it's about 10 because I can see that. And then if I hook into it, that hooks in good. That slips, doesn't do me any good. And that's too coarse. Bam, it's 10 by 125. I can verify that by dropping it on the floor. I can verify that by screwing it in there. Screw it to it! Like Pruitt Hewitt used to do it to it. So being as sure as I am that it's 10 by 1.25, I don't mind sending a tap into that kickstand. Put a lot of work into that kickstand. Given I put a lot of work in, let's make it work. So I'm going to use a 7500 and some other hand tools basically. This is a socket that's made to fit these things so that you can get them going real straight. If you're no stranger to the channel, you'll know I use a lot of wobble extensions. Make sure they're not. Make sure they're square for this portion of the activity. Ha ha! Now we gotta hook up. I like these sockets. If you don't have the sockets, then you have to use a big old T-handle thing, and it sucks. That's what I'm going to say. I'm liking these. So I've heard of them. I've wished I had them in the past. So I bought a set. I'll leave a link in the description. You can do the same if you like. No pressure, but I do get a nickel or two if you do. And nickels add up. Quick nickel's better than a slow dime, right? Ba 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 ba. Ladies and gentlemen, I think this is going to work. I love how straight you can get that, and I love the force and pressure you can put on that with a socket. I've made my own sockets in the past and loved them, and I was just like, man, I ought to get some, but you never remember to do it, and then you need it, and then you need it again and again and again. I don't know why we don't do this from the get-go. Why do we got to use these? Look at the size of the T-handle in this. Look at the size of that. Try getting that straight. The weight of the wings of it, it's problematic. Ha ha, look at that. Look at that. So we got a little wear on that bottom side. Go figure. There's a couple ways to handle that. If you have a welder, you can weld it in and then round it up in the vise. If you don't have a welder, you can back it off and then tighten the nut on the other side. If you're thinking, man, that'll work. I'm going to weld it because I got one. Here's a hot little tamale. I can tell you how it fills. It fills the hole in great. It feels really hot. I'm going to put it in the vise. So here is my rectified bolt. It's a little bit skinnier at the bottom. I got into it with a flap disc more than I intended. A little high spot there. The main part, you can see there's a little gap. That's basically that low spot there used to dive in lower. So I got material where I wanted it. There didn't used to be. It's probably too hot. Look how nice that is. Look how smooth that is. When I first did it, it rattled around a bit. It's going great now. Threads are good. It's nice and round. It's not hanging up on anything. I'll take it. I didn't have to wait for shipping. I didn't have to pay any money. Just a little bit of materials. That's all it took. Little time, little materials. Like doing a puzzle. It's not pretty, but it's pretty tight. There's not much wiggle in it now. There's just a little bit up and down, whereas it used to be really floppy. Let's get this down here. You see, there's just a little, and that's acceptable. I don't know what it is on a new bike, but I bet it's close to that. I got these surfaces all done. You can see that that's a little goopy looking on the inside, but you can't see the inside once we're done. What you can see is just about nothing once it's all covered up and painted and squared away, so I'm happy with it. That's going to be awesome. It's going to work great. So we've done a little test fit before grease and paint. Once the spring's on, it'll help give that last little bit. I like it. Not bad. Well, that's way better. Clearly, this wheel gloss is going to help. So this is made to just spray right onto the wheels. This is still kind of hot. This will do, not miracles obviously, but it'll actually help a lot to reduce any rust. Ta-da! So back before I even did a YouTube channel, a guy at Duplicolor on the Facebook page was like, try our engine paint, and I piped in. I love that stuff. I use the black all the time for everything. That's what we'll be using here. Dude sent, he's like, what's your address? He sent me 6 cans. I was Joe Schmo at the time, you know, as far as social media goes. So anyway, shout out to those guys for just being cool to anybody and everybody. I don't know if they're going to do it now, but man, what a difference that makes, right? And we can't forget, we gotta spray our little doodad that we did for our ground. Bam. So I'm going to take the cardboard and do a little ninja trick here. Take off a little bit, and it will flow in to fill that in. This looks like crap because it's still too hot. It's bubbling. So I'm going to have to sand and reshoot that or just see if it flows out. Ceramic paint is the shiznit. That means it's really cool. So here's how it turned out. It's not too bad. Turned out pretty square despite just blobbing it up and shaving it down. I go to test fit it with the paint on, and it don't want none with the paint. The paint makes the tolerance too tight. That's a tight enough tolerance. It's going to scrape the paint off anyway, so I'm just going to scrape it with a knife and replace it with grease. It'll wear any way you look at it, but all those top surfaces off. That's better. I was trying to get it so tight. There's some futility to that. So let's take a little bit of grease, put it on the top surface here. It's going to mess up with the paint a little bit. I'm going to put a little on the bottom surface, and then just kind of do the same thing. A little in the hole. Put a little on the bolt itself. What a weird word, itself. I used to hear that a lot when I lived in India. A lot of the locals would say that. That's weird. That is like brand new. It's perfect. Just a little bit of motion. Moves freely. So I'll follow that up with the nylock, whatever you want to call it. Wipe it off, get all the grease off, the excess. On most bikes, this is all you have to do. This one's just special because it's a Vulcan. Vulcan's a good bike, but there's some quirky stuff going on with this design. slide the fork in first. Get this positioned underneath. I've got the bolt stored right here. Cue the T Allen wrench. This is a way better order of operations than what I was going to attempt before. Repair took a lot longer than I thought it would. It also turned out every bit as good as I thought it would. I think the owner's really going to like this. So we need to connect this stud here to this stud here via the spring. And the best way to do that is to pull straight back on it. Put the bike in gear, use a spring hook like this, and then pull it back. When it's in the down position is when it's stretched the longest, so it can pull it back up. So we're gonna have to put one of our shifters back on for just a second so that we can get that first gear rocket just a hair. Look how much play there is on this. It's almost nothing. It used to be able to go all the way. Now it's just a teeny bit. So there's a bunch of sensor stuff up in here, so you want to use your span. This one has a double spring. It's just two springs that are stacked or bent or whatever together. So you want to do this one here, because then it can't really get in contact with anything there. So hook into the spring. Nice thing about spring pullover is you can roll it over like that. Smooth and quiet. I think he's gonna like it. Pretty good result. Look how rock solid this thing is. Hardly moves at all. So there you have it. No bungee cord. We've got a spring back in place. You can't see really much of anything. If you look just right, you kind of can. But overall, nobody's ever going to notice that. But what you will notice is that the kickstand works awesome now.